image from the James Webb Telescope to mark 1 year since it started sending us images from deep space.
There was a universe. We'd just begun to discover that distant galaxies have stars in them.
What the James Webb Space Telescope just saw wasn't supposed to be there. In its mission to peer into the ancient past, closer to the Big Bang than ever before, it captured something that's left scientists stunned and scrambling for answers. Galaxies that are too old, too massive, and too structured to exist at such an early time. And now, a Nobel Prize-winning physicist has stepped forward with a chilling warning. This could be evidence of a parallel universe, or something far stranger. Is the universe we know just one of many? Has James Webb accidentally uncovered proof that reality is far more complex than we imagined? In this video, we break down exactly what was found and why it might rewrite the laws of cosmology, the telescope that shattered the universe's timeline. Imagine someone standing up and saying, "Let's build a telescope that can see back to the Big Bang." At first, it sounds like science fiction, but that's exactly what humanity did with the James Webb Space Telescope. And it didn't just peer into deep space, it tore a hole in our understanding of the cosmos. What it saw out there was not just awe-inspiring, it was deeply unsettling. Galaxies where there should be none, light where there should be darkness, and order where there should only be chaos. These weren't faint whispers from the dawn of time. These were massive, brilliant galaxies, some even larger than our own, lighting up Webb's infrared sensors like fireworks. Webb wasn't supposed to find this. The early universe, just a few 100 million years old, should have been empty, dark, and slow to build. The standard models predicted that the first galaxies would be dim, disorganized clumps of gas and dust, slowly inching toward complexity. But what Webb revealed looked nothing like that. Instead, it uncovered fully formed galaxies, packed with stars, structured and mature, like the universe had skipped its childhood and jumped straight into adulthood. One glowing yellow galaxy stood out. At first, astronomers assumed it had to be close. It simply looked too bright and too big to be from the early universe. But when the spectroscopic data came in, it told a very different story. That galaxy wasn't nearby at all. Its light had traveled more than 13 billion years to reach us. And it wasn't alone. All across Webb's early deep-field images, similar bright and dense galaxies appeared, each one a direct challenge to everything cosmologists thought they knew. To form something so massive that early in cosmic history, you'd need stars. To get stars, you need clouds of dust and gas to collapse under gravity. And that process takes time. Lots of time. But the early universe, the one captured in these Webb images, didn't seem to have that time to spare. Scientists tried to explain the results away. Maybe it was an error in the telescope. Maybe they misread the data. But the patterns held. Image after image confirmed it. Teams across the world replicated the results. The mystery refused to go away. Suddenly the question resurfaced, how did we get here? And if these galaxies really existed, if the evidence stood up to scrutiny, then the early universe must have operated by rules we don't yet understand. That's a terrifying thought, because it suggests our entire model of the universe, the one we've trusted for decades, might be wrong. For years, the Lambda CDM model sat at the core of modern cosmology. This framework relied on the idea that the universe is made mostly of cold, dark matter, and it expands under the force of dark energy. It explained galaxy formation, cosmic background radiation, and how space has stretched over billions of years. But now, cracks are forming. Webb's discoveries don't just stretch the Lambda CDM model, they tear at its very fabric. The galaxies aren't just slightly too big or slightly too early, they're wildly out of sync with what the model predicts. According to the math, the early universe simply didn't have enough material or time to build galaxies of this size, not unless it converted nearly all of its available hydrogen and helium, the raw stuff left after the Big Bang, into stars with perfect efficiency. But we've never seen nature move that fast. Even in today's most aggressive star-forming regions, that conversion remains slow and wasteful. Scientists tried tweaking the variables. Maybe stars formed more efficiently in the early universe. Maybe there was more dust or more gas than we expected. But none of those fixes held up. each adjustment introduced new problems, breaking the model elsewhere. The situation became clear. This wasn't just a data issue. The foundation itself had problems. And for the first time in a long while, even Nobel Prize-winning scientists started talking openly about it. Some of them now propose that dark matter behaved differently during those early epochs. Others float theories involving entirely new forms of physics, concepts so radical we haven't even named them yet. One bold hypothesis suggests we're not looking at early galaxies at all. These luminous bodies might be something else entirely. And that's where things get even stranger. Cosmic illusions, fractured timelines, and a universe that shouldn't exist. If the James Webb Space Telescope didn't uncover young galaxies, then what did it see? Some researchers believe we may have misunderstood the very nature of time and structure in the early universe. What if time moved differently back then? What if the expansion of space didn't unfold uniformly? Could we be looking at snapshots of objects from parallel timelines? Or, worse, a universe within a universe? The idea may sound outrageous, but so did the Big Bang once. And now, evidence is stacking up that something fundamentally offbeat shaped the cosmos we live in. What Webb saw might not just be a fluke of physics. It could be a glitch in our entire perception of reality. Other experts are exploring whether these galaxies might be products of exotic matter or interactions we've never observed. In that case, they wouldn't be galaxies at all, but some other type of luminous structure that mimics them. And if that's true, then Webb may not have just rewritten the history of space. It may have accidentally opened a door to something far more alien than we expected. These possibilities hint at a profound shift in our understanding of the cosmos, not just in the details of star formation or galactic mass, but in the very nature of space, time, and matter. If Webb's data continues to hold, and so far, all signs say it will, then scientists may have to build an entirely new framework. Not just patch the old one, but throw it out and start over. What does this mean for the average person? It means that we're living in a universe we don't yet understand. The ground beneath our theories feels less stable than ever. But in that uncertainty lies excitement, discovery, mystery. Webb has become more than just a telescope. It's a mirror reflecting our ignorance and an eye staring deeper than we ever thought possible. And this is just the beginning, because the Webb telescope hasn't even begun to reveal its full capabilities. Every year, it will dig deeper, see farther, detect fainter whispers from the birth of everything. If these first few images shattered our models, imagine what happens when we get 10 times the data, or 100. The early universe, what we thought of as simple and slow, is revealing itself to be fast, bright, and wildly creative. The rules are changing. The script is being rewritten. And as we stare into that endless black sky, one thing becomes clear. The cosmos is far stranger than we ever dared to imagine, and the James Webb Space Telescope has only just opened the curtain. The galaxies that shouldn't exist, and the model that can't explain them. Imagine someone said, "Let's build a telescope that can look all the way back to the Big Bang." Sounds impossible, right? But the James Webb Space Telescope isn't just doing that, it's uncovering something far weirder, something that doesn't just challenge what we know about space, but possibly everything we know about time, matter, and reality itself. When the telescope started sending its first images, scientists expected faint specks, dim, infant galaxies, slowly forming in the cosmic dawn. Instead, they saw an explosion of brightness, a cosmic crowd of fully formed galaxies glowing where darkness should have ruled. Those little specks of light in the images, they aren't just stars, they're entire galaxies, some bigger than our Milky Way, sitting just a few 100 million years after the Big Bang. According to physics, that's not enough time for anything that big to exist. The gas and dust in the early universe shouldn't have had the time to clump together, ignite, and give birth to stars on this scale. But the Webb telescope doesn't lie. Spectroscopy confirmed it. The light from these galaxies traveled over 13 billion years just to reach us, and it's showing us galaxies that shouldn't be there. One object, an unusually bright yellow blob, really caught scientists off guard. Initially, they thought it must be close by, because of how luminous and massive it appeared, but when they measured its distance, it turned out to be one of the farthest galaxies ever recorded. It wasn't an anomaly. Webb's early images revealed more of these dense, structured galaxies scattered across space like cosmic seeds. These weren't the chaotic, faint, primitive galaxies predicted by our models. They looked mature, organized, packed with stars, and old, as if the early universe skipped the awkward growing up phase entirely. So how could something like this exist so soon after the beginning of time? To build stars, you need dust and gas. To gather that dust and gas, you need gravity and time, lots of it. Yet here we are, looking at galaxies that behaved like they had all the time in the world when the clock had only just started ticking. Scientists scrambled to explain it. Some thought the telescope might have malfunctioned. Others questioned the data. But as more images arrived and teams across the globe confirmed the results, the doubts fell away. This wasn't an error. It was a crack in the foundation of modern cosmology. For decades, the Lambda CDM model stood as the gold standard in our understanding of the universe. This model explains galaxy formation, cosmic expansion, and the balance of visible matter, and dark energy. But these findings, they don't just stretch the model, they break it. The galaxies Webb uncovered aren't just early, they're too massive, too bright, and too numerous. According to Lambda CDM, nothing should have had the time or material to become that big so fast. The math doesn't work. Even in the fastest star-forming galaxies we've seen, turning raw hydrogen and helium into stars takes time and efficiency. These galaxies turned nearly all their gas into stars immediately. That's not just rare, that's impossible by our current physics. Some scientists tried tweaking the model, upping the star formation rates, or adding more starting material, but every adjustment caused another part of the model to fail, like patching one leak in a dam only to watch 3 more burst open. It wasn't the math that was broken, it was the assumptions beneath it. Even Nobel-winning scientists began to voice their doubts publicly. Maybe dark matter behaves differently in the early universe. Maybe new physics are at play. And maybe, just maybe, these aren't even galaxies at all. What if Webb isn't showing us early galaxies? What if it's revealing a class of objects we've never seen? Structures that don't match anything in our catalogues. These objects don't spin like normal galaxies. They don't look like spirals or ellipses. They appear compact, irregular, and wildly bright, more like cosmic fossils from a reality we weren't supposed to see. Spectroscopic data revealed another strange truth. Many of these objects had burned through all their gas. In modern galaxies, only a small percentage of gas turns into stars. The rest drifts in clouds, waiting for gravity to do its job. But these early objects had no leftovers. They were pure starlight, fully spent. That kind of efficiency is unheard of. It breaks the known rules of galaxy evolution. An object that burns all its fuel can't grow. It dies quickly. But these weren't collapsing. They stood frozen in time, glowing from the edge of creation. So astronomers asked the uncomfortable question, what if these aren't galaxies? Maybe they're massive star clusters, ancient quasars, or remnants of a previous universe, somehow lingering past a cosmic reset. Others wondered if these were completely new cosmic objects, things we've never imagined, let alone named. And if they aren't galaxies, what does that say about our own cosmic origin? Because our entire story of the universe rests on the idea that galaxies form the building blocks of cosmic structure. If those blocks turn out to be something else, then the entire architecture collapses. Which brings us to a much bigger question. What are we really looking at when we stare into deep space? The edge of time, and what might lie beyond it? Looking into space means looking into the past. Every galaxy, every beam of light we see comes from a different chapter of the universe's history, and the James Webb Space Telescope is reading deeper into that story than any instrument before it.
To create the most advanced telescope ever built.
But there's a catch. We can only see so far the observable universe. It stretches about 92 billion light-years across, a massive sphere centered on Earth. Beyond it, we hit a wall. Not because nothing exists out there, but because light from beyond that boundary hasn't had enough time to reach us. And it gets weirder. The universe is expanding, not slowly, but at an accelerating pace. Galaxies at the edge of visibility are already moving away from us faster than light. That sounds like it should break the rules of physics, but because space itself is expanding, not the objects within it, the rules bend in strange ways. We still catch glimpses of their ancient light. It curves, stretches, and flows through expanding space like ink across water. This is how Webb can see galaxies that logic says should be out of reach. But there's a boundary we'll never cross. The cosmic horizon. Beyond it, no information can ever arrive. Not now, not ever. Yet that doesn't mean nothing exists out there. Most cosmologists believe the universe continues far past what we can see. If it stretches to infinity, then the Big Bang wasn't an explosion from a point. It was an expansion of space itself, happening everywhere at once. Everywhere includes regions we'll never touch, never see, never know, but they're real. And here's the twist. When we stare at the edge of the observable universe, we're not seeing the end of space. We're staring into the limits of our own perception. Beyond that lies, possibly, another universe, or another version of this one, maybe even both. The Big Bang didn't create a central explosion. It triggered a moment that happened everywhere, including the most distant corners of the cosmos. That moment still echoes around us in the form of the cosmic microwave background.
And the cosmic microwave background radiation that we see everywhere in the universe.
A dim glow from the universe's first light, wrapping us in ancient energy. But the new data throws even that into question. If galaxies, or whatever they are, already existed with stars just 200 million years after the Big Bang, then our timeline might be flawed. Maybe time flowed differently in the early universe. Or maybe these objects weren't part of the Big Bang at all. Maybe they're visitors from somewhere else, ghosts from a parallel universe bleeding into our own.
The Pillars of Creation is a star-forming region within our Milky Way galaxy.
When the universe broke the rules, and what that means for reality. Some scientists now believe that under the extreme conditions of the early universe, even our most basic ideas, like before and after, could break down. The rules we depend on today, from gravity to the speed of light, might not have worked the same way in those first moments. And that opens a door to something far stranger than we've ever considered. Maybe the universe didn't begin the way we think it did. What if the Big Bang wasn't a birth, but a transformation? A phase shift from something older, something timeless, or something completely beyond our imagination. That would mean other phases could have come before ours, other realities, maybe even other universes. So now we face a mind-bending question. What really happened at the start of time? And if time itself has no true beginning, what does that mean for the universe? And for us? This isn't just philosophical pondering anymore. A recent study published in the Astrophysical Journal added serious weight to the cosmic mystery. Astronomers used the James Webb Space Telescope to identify something staggering: 87 galaxies that appeared just 200 to 400 million years after the Big Bang. That's barely 500 million years into the universe's life. By every established model, that's impossible. Galaxies aren't supposed to form that quickly. Gas clouds need to collapse under gravity, ignite as stars, then gradually organize into clusters and galaxies. That kind of structure takes time, hundreds of millions of years at least. But here we are, staring at cosmic cities that seem to have sprung up on page 1 of the universe's storybook. And these galaxies aren't just early, they're mature. They show structure, brightness, and mass on a scale scientists didn't expect to see for billions of years. If even a handful of these galaxies are real, they destroy the timeline we've relied on for decades. Jing Yan, one of the study's lead researchers, put it bluntly: even a few confirmed cases would force us to rethink everything about the early universe. These galaxies didn't just form quickly, they formed too well. Some packed in more mass than should be possible in such a short time frame. Others birthed stars at rates no current theory can explain. Taken together, they don't look like cosmic anomalies. They form a pattern, and James Webb keeps finding more of them. The universe, it seems, is speaking loud and clear. Our cosmic clock might be broken. So now what? Faced with discoveries that don't fit any known model, the scientific community has arrived at a crossroads. Do we try to tweak existing theories to fit the new data? Or do we accept that something fundamental is missing from our understanding of reality? Some researchers are already pushing for bold, outside-the-box ideas. Maybe dark matter plays a more active role than we assumed. Maybe the laws of physics change in extreme cosmic environments. Others have proposed even stranger possibilities, like a variable speed of light, ancient black holes seeding early galaxies, or quantum effects on a cosmic scale. Every idea tries to make sense of what we're seeing. None explain it all, and that leads to the most radical theory of all, one that's both thrilling and terrifying. What if these galaxies, or objects that look like galaxies, aren't part of our universe as we understand it? What if they're traces of another reality, a different cosmos stitched into our own through some unknown mechanism? If the multiverse exists, these early structures could be cosmic scars left behind by a neighboring universe bleeding into ours. Right now, these are just theories, ideas sparked by strange data and deep curiosity. But that's how science moves forward. Not by staying comfortable, but by confronting what we don't understand. Some scientists urge caution, and rightly so. They remind us that extraordinary claims demand extraordinary evidence. But the evidence is mounting, slowly, relentlessly. James Webb was built to observe the first light in the universe. Its mission was to detect the very first stars and galaxies. Instead, it may have pulled back the curtain on something deeper, something more profound. We're not just rewriting astronomy textbooks. We may be rewriting the nature of reality itself. So where do we go from here? We keep looking, we keep questioning, and we brace ourselves for answers that may sound more like science fiction than science fact. Because when the universe whispers secrets from 13 billion years ago, we'd be foolish to cover our ears. We've looked into the farthest reaches of space and found questions, not answers. The James Webb Telescope didn't just uncover distant galaxies. It uncovered a cosmic riddle that cuts through the heart of what we believe. Galaxies that form too fast, objects that shouldn't exist, a timeline that no longer fits. Even Nobel Prize-winning physicists admit they're baffled. Is this really the beginning of time we're witnessing? Or something else entirely? A new kind of object, a different kind of universe, a truth we've never imagined. Whatever it is, we're just beginning to understand it. And as we peer deeper into that eternal night, one thing becomes unmistakably clear. This mystery isn't over, not even close. All right? So that's it for this video. And if you want to watch more amazing content like this, check out some of our other videos. Bye.